Hi, this is Kiran. I'm the host for this video. I'm going to demonstrate computer questions you can learn and improve your knowledge. This is collection 2. Let's straight away jump into the questions. The first question is, which generation of computers use transistors? The options are below. First generation, second generation, fourth generation. You can see the option is second generation. More details are provided over here. Generations of computer. In the first generation, you can see it is from 1939 to 1957. Vacuum tubes are used efficiently at that stage. Then comes the second generation, our answer. It is for 1957 to 59. At this stage, you can see transistors are used. Next up is third generation from 1959 to 1971. ICs are used at that stage. From 1971 to 1990, we call it as a fourth generation. Microprocessors are used that time. And the fifth generation or even beyond, you can see artificial intelligence, the robotics are coming into picture. So for this answer, it should be second generation. In modems, what's the option? Pretty much close. Whether it's several digital signals are multiplexed, a digital signal changes some characteristics of a carrier wave, or digital signal is amplified. So in this case, option B is pretty much close. We can show that as part of this image, the digital signal, which is in digital format, ones and zeros, are converted into some analog format over here. You can see. So the characteristics here are changed. So this is the modulated signal. So the option B is pretty much close over here. In digital data transmission, what is the relation between baud rate and bit rate? He is telling whether it is always equal or always smaller or always greater, or it's a constant. First, we need to know what is the relation between baud rate and bit rate so that we can answer this one easily. The option here is none of these. None is satisfying over here. The reason, you can see an analog signal carries 4 bits in each signal element. If 1000 signal elements are sent per second, find the baud rate and bit rate. If you answer this question, you can understand the concept of baud rate and bit rate. The solution, you can see baud rate equal to number of signal elements per second, how many bauds are coming. So bit rate is baud rate into number of bits per signal. In this case, 1000 bauds, and each baud has how many bits. So total it should be 4000. In this case, bit rate is greater than baud rate, but there could be a chance like a signal element has only 1 bit. In that case, a baud rate and bit rate is same. This example shows baud rate is less than bit rate, but this is not the case all the time because he is mentioning always. That's the reason we cannot select this option. And equal to can also not be possible all the time. So always is a tricky word used over here. So these two are not at all coming into picture. So the answer could be if it is less than or equal to, the baud rate can be less than or equal to. That's the option which we can select, but it is not there. It is in split format. This one and this one together, it's fine. Either option should be A or B or none of these. So in this case, none of these is the option. Information retrieval is fastest from dash. Out of these available options, which one is faster? It's clearly the hard disk. You can see this table over here. A floppy disk, it is the lowest. It is the direct access. For the hard disk, it is the highest and very high. Even capacity wise, it is high. Floppy disk is very less, 3.4 mm. And nowadays we are not using this. Hard disk are pretty close and most of them we are using it. Nowadays it's in terabytes. And magnetic tapes, it's used for storage purpose. Cost is also high and capacity is too high, but the only disadvantage is sequential. So when the retrieval demands sequential and you can store huge amounts, then you should go for magnetic tape. But in this case, he is asking the fastest, so you need to choose hard disk. Which of the following topology is highly reliable? So in this case, it should be fully connected mesh, but when cost is not a matter, in this case he didn't mention anything about it. So this is how it looks like. These are computer terminals and all are connected to each other. Means you can see a flow of data from here to any of the computers. The same is the case from any other computer to any other computer. It is very reliable. Even there is a break over here, the data can flow and find out. Means this computer can easily reach out to the other computer. But the only problem is high cost in laying down all these things. Here the picture, you can see only 6 computers, but in a real world, when you want to connect hundreds of computers, it's very tough to have this kind of topology. Which of the following topologies is used for broadcasting type? So the answer should be ring. You can see the picture over here how this is connected compared to earlier mesh. In the mesh you can see everything is interconnected to each other, but in this case that is not the case. So the cost is bit lesser, and also it's used for broadcasting. For example, he generated some information, it can be sent over to this guy, and this guy in turn sends the package this guy and whole in a circular format, but actual information is passed through all computers, so it's pretty much popular in broadcasting type. A device that both transmits and receives the data. So he had given an option so here, but option D is well suits for this. And here comes the picture, one of the example how the transceiver works. This is a hand transceiver. In short, it is called HT. It both transmits and receives the radio signals. But the only disadvantage is you cannot do together. You need to say completed or some terminology where other guy can start his conversation and he stops, then this conversation starts. But this acts as both sending as well as receiving the data. Which of the following is an abbreviation for a hardware programming language? So the option is AHPL. A group of signal lines used to transmit data in parallel from one element of a computer to another. So how that's happening? Through lines. So you must have seen that in your computer preparation. So whether is it control bus, address bus, or the data bus, the option should be at the data bus. You can see it in the picture. Here comes the CPU, memory and input. There are three types of them: control bus, address bus and data bus, but he is talking majorly about a data, so data should always go to the data bus. Allocator and manager of memory in an operating system is done by whom? Keyboard, it's simply used to punch in the keys. Key punch is also not a matter, so it's always the kernel. It is the heart of the operating system. Here comes your CPU, memory and devices, all your hardware and all your software applications reside in top level, but in between a kernel who is going to do the job of interaction between applications and behind the scenes the resources. So it fetches, it does all the operations and give responses to the applications where end users sit here and enjoy the stuff. Which of the following is not a factor affecting the processing capability or performance of a PC system? So you can see which is not part of processing capability. Clock speed, of course it is part of it as part of a microprocessor. Revolutions per minute of a printer disk, this cannot be the option. Let us check the other ones. Primary storage, yes, storage is must because it needs to get instructions from it. The built-in instruction set available to the microprocessor. So out of this, only option B is a culprit, odd out, we can remove. A language based on graphics for use in education is called Dash. So in education, which one is heavily used? So we already know COBOL is for business oriented. So the option here is logo. You can create pretty much easy logos over here. It's pretty nice to explain to children to start with at this point of time. You can use some of these commands over here. We call this one as a turtle, the cursor point. If you say forward 50, it moves from down to top, and right, the turtle just turns its direction from this to this. Here you see, and it doesn't move, it just rotates 90 degrees. Then if you say forward 50, it provides one more line. So to make a complete square over here, you need to put all these instructions: forward 50, 90, and this and this. There are n number of programs available online you can download, and it's a small compiler through which you can write this language and create some beautiful designs with simple instructions. So it's pretty much good for educational purposes. Which of the following is a particular form of magnetic tape cartridge? So what's the one which is an example for it? So card punch, no. The answer should be a digital cassette. You can see this is how while we were child we used these things more. You must have played a lot with these things. We used to use audio. In general, it can store a lot of data. Only disadvantage is it is sequential. The ability of a subsystem to be substituted for the original designated equipment. So what is that? Is it versatility, compatibility, reliability, computability? Option B is pretty close, compatibility. You can see how this new object of different color can be easily set into the existing one. This is possible only due to the design. It has its cutout over here as well as some additional information over here. So these two are sticking together to make on the whole a simple object. So that's the reason we need to choose this option. Which memory is used in high performance systems? Inserted between the processor and memory. To improve the performance, what is the component that we are going to use it? That too in between processor and memory. So ROM, SAM, this we haven't heard about. And RAM, this is by default the memory that he's talking about. So the option should be cache. This speeds up your processing speed and the end results will come quickly. Here you see pictorially that memory sits on top, cache in between, and CPU on the bottom. So whenever CPU wants some information, it first checks in the cache. If it finds that information, it fetches and does the operations. Else, then only it goes to a memory. So you see, a fetching from memory takes more time and from cache it's quicker. But the only disadvantage is cache can be pretty costly and of less size. The amount of information stored in cache depends your performance. So if the information is not there, as mentioned, it goes to the memory. But for this question, which sits in the middle to improve performance, it should be your cache. A type of memory chip whose contents cannot be altered by writing data. So what type of a memory chip it is? Read once and that's it. There is no alterations. PROM, it's a programmable, so it comes closer, but when there is a ROM in a picture, then your answer should be ROM because it's a program once and that's it. Here comes the picture. It's an enlarged version, but these are pretty tiny pieces which sits inside your motherboard. EPROM is erasable programming, so these things will not come into picture. So your answer should be ROM for such answers where the data cannot be altered once it is written. The shifting of a program from one of the memory address to another one is. So what is that called? The option should be relocation. Relocation is an option. You can see it in the picture. Program relocation. You can see a CPU is coming here. It is generating an address 346, but the actual address is in 14346. So who is helping that? A relocation register by adding it to the existing logical address, and it provides the physical address. And assume 14,000 starts from here, so it adds up, go to 14346 by adding this 346 to this register. Thus relocation is an option he is expecting from this, the shifting of a program from one memory address to another. Hope you understood this. The amount of time is taken up in getting data from a disk. What is it called? Whether it is a delay time, access time, real time, or a latency. So the option should be a latency over here. Here comes a simple picture of a disk. This is the read-write head. These are the tracks. And this part is called the sector. So the amount of time it takes to reach to appropriate sector over here and pull that data out, the whole time is called what? It is called the latency. The process used to set up a program once the system is operational is called dash. So what is that process called? Operating system? No, not at all. Blackbone? Never heard about it. Bootstrap, yes, this is the one you need to choose, and utilities are not coming into this picture. So it is used to set up a program once and the system is in operational. You can read some more stuff over here. The main memory has a small section of permanent read-only memory, a ROM, and ROM in turn consists of a program called a bootstrap program. And at the start, the CPU runs bootstrap, which directs the CPU to load the operating system from the disk. Means it knows the link where the OS is residing. So if this is corrupted, gone, you'll be seeing some blue screens and you need to reformat and reinstall your operating system. So it's pretty important when it comes to a loading of your operating system and for the booting process. Which is a programming language for military applications. So you must have seen the COBOL, C, Fortran for different operations. So Corel is the one you need to choose in this case. This is heavily used for military applications. A way of checking the data have been moved or stored correctly. We already discussed in our earlier videos, but in case you forgot, the option should be a C. There is a parity bit. We can demonstrate the same in this 8-bit code. Here it is 9 bits. So 1 bit is allocated completely for the parity and the remaining is a binary which defines what type of character it is. You can either follow the odd parity or even parity by entering the last digit. So the main option here is in the odd parity, it tries to make the number of ones to be always 1. For example, the whole information contains 1, 2, 3. It's an odd number. So it provides 0 to don't disturb that stuff. But in the bottom, you see it's 1. So already it is 1, so only 0 is added over here. For the odd parity, you can see the total number of ones are 1, 2, 3, 4. So you need to add 1 to make it odd. Similarly 1, 2, so you need to add always 1. So this is the different scenarios you are following. But in this case, a parity bit is an 8-bit total Out of total 8 bits, 7 bits are used for this and 1 bit for parity. So always remember, this parity bit is used to do a checking as well as verification while you are moving or storing a data. Translator of a high level language into the object code, we already discussed this. So the option should be compiler, a simple snippet. Assume this is a C code, a source code, and a compiler, C compiler. Once you compile, it creates an object file with little binaries as well as some library references. So the linker knows where the libraries, which one to be used. Finally, it creates the executable file, which is dependent on a particular operating system and a machine. So here the question is from which format to which format, or which one will be changing. In this case, a source code is a high level code and object code is here. So who is that guy who is creating it? It's the compiler. So option C is the one you need to choose. A built-in number that identifies a location in a storage is known as dash. So what do we call? It is called the address. So you need to choose address, which is the number, built-in number that identifies the location. A sequence of one or more characters is called dash. So it's a string. So you need to choose string when you see one or more characters. So these things can be heavily used in your operating systems, programming languages. A sizable geographical area with communication based on a telephone system is through a dash. Whether it is a LAN, LAN, or it is a WAN, modular or demodulator, these two never be the case in this. So neither the demodulator, there could be slight difference between local area network and wide area network, but in this case he is telling a sizable geographical area, so you should go slightly lower one, that is wide area network. If it is LAN, it is much smaller than even wide area network. You can see the same in a picture to understand better. So here comes the WAN sits in the middle, wherein this could be one LAN, this could be one LAN, this could be one LAN interconnected. So all the LANs and this whole thing is residing in one small area. This could not be much bigger. A multiple WANs together can become an internet, but in this case wide area network is the thing that he is asking, so you need to be very careful about it. Thanks for watching this video. This is Kiran signing off. Have a good day. Keep watching to this and subscribe to this channel.